Okay, so our next step is to create a box and then assemble a crank handle, axle, box follower, and a cam. So whenever we turn the handle, everything rotates. So first thing you have to create those things. So box follower I made like this with a simple extrusion and a revolution. This extrusion was 3 inches and this was just some generic shape that I revolved. In order for us to assemble it later, we have to turn on the visibility for some work planes. So I'm going to turn on the visibility of XZ plane. I expanded the origin, and here under the origin I made a YZ plane visible. So right now you can see that it goes right through the middle of the shape. Then I created a crank. It also doesn't have to be this, something that like a handle that will go on the side of your box that you can rotate. And we also will need to expand the origin and then turn on the visibility of one of the planes, so YZ in my case. Next one is crankshaft or an axle. I made it about 6 inches long, and we also will need the plane that goes through the entire length, and that's YZ for me. I'm going to check the visibility for that as well. For the cam, I think yesterday I told you to extrude it. Whenever you were extruding it, I told you to use just the default extrusion, and I forgot to mention that it had to be symmetric, so you have to change it to this. Okay, so once you change it to this, we're going to turn on the visibility of some of the planes too. I will need the plane that goes through the middle of my hole, so XZ, and then a plane that goes through the entire length of the cam, so XY plane. So you can have one here and then one through the sides. Okay, then I also build a box. The dimensions for the box are on your deliverable sheet, and the only thing I mentioned that the side piece will have to have a hole in the middle. The way I built mine, that it was centered around the origin. So my sketch was, I used the polygon feature, and I used 4-sided polygon, which is a square, so my semicircle was exactly in the middle. If you did not use the origin as your center, you can always take a construction line and make 2 diagonals. An intersection of those 2 diagonals will be the center of your square, and you can put a point there and make an extrusion that way. Okay. Okay, and also on my top piece, I also drilled 2 holes. And again, whenever I created mine, I used the rectangle feature and I constrained it, coincided the center to the center. And I made 2 holes 1 inch away from the center. You don't have to do it this way, you just have to be somewhere on the mid plane, or on the midline. And based on your design, your dimensions could be different. So go ahead and place everything into the assembly and assemble the box. So your box should look somewhat like this. 2 sides, back, and tops. Okay. Then we will place into the box assembly, we will place a cam, crank, box follower, and an axle. So the first thing I'm going to constrain, I'm going to put an axle inside of those holes. So I'm going to make an axis of an axle or crankshaft and the axis of the hole. And then I'm going to flush the back of this axle with the side. Okay, so that should do it. And the next thing I'm going to place the handle on it. So again, made axis of this hole and of this, and I'm going to flush this side with this. Okay, so now you can see that I can rotate the crank handle, but my axle does not rotate. So that's where the angle constraints come in handy. So I'm going to select angle, and I'm going to select the first option here, directed angle, and I'm going to select this work plane with this work plane right here. So right now they're constrained at 0 degrees, but I can also offset the degree. So for example, if I do 90 degrees, you can see that it rotates in 90 degrees. I'm going to go back to 0 because it doesn't matter at this point. Okay, I'm going to hit apply. So now you guys can see that when I rotate the handle, axle rotates as well. Next thing I'm going to do, I'm going to place box follower inside of the hole. And that's going to be enough for now. I'm going to pull it up a little bit. And then I'm going to place cam on the axle. And what you can see right now that although they're constrained, they're not aligned to one another. So I'm going to mate the planes of one and the other, which will put them directly below one another. Okay. And let's see what it's doing now. So I can rotate the handle, but nothing rotates. So we're going to use the same angle constraint of this axis and this, sorry, that plane and this plane. Directed angle again. And this is where angle will come in handy whenever you guys design your own automatas. You can adjust the angles and the cam will rotate. So different cams will be assigned to different degrees. I'm going to hit apply, and now you can see that this handle rotates the cam. So the last thing to do is to make sure that the box follower follows the cam. There are two different ways to do this. You can use tangent constraint, so tangent, and select the bottom of your follower with the surface of the cam. Let's see if it's working. Does not work that well. Okay, so what we're going to try to do is we're going to delete this and try to constrain it instead to the surface here, this surface. Let's see if this will work. Looks like it doesn't work either. Okay, well, I'm going to show you the other way around, and I'm going to play with tangent later. Okay, so next one is transitional constraint. I'm going to take this and constrain it to this. Hit apply. And now we can try to rotate the handle, the cam, and the follower follows the rotation. Okay, so looks like the transitional constraint works better. However, I found with different cams, tangent works as well. So you guys go ahead and play around with this. So your goal right now is to put the second cam on and the second box follower and make them attached.